Hello students, let's do playing with numbers exercise 3.5. Question 7. The sum of two consecutive odd numbers is divisible by 4. Verify the statement with the help of some examples. So we've been given a statement here, and what is that statement? The sum of two consecutive odd numbers is divisible by 4. Okay, so let's write down some odd numbers. Okay, starting with 1. So 1, then 3, 5, 7, 9, 11, 13. Now we have many more odd numbers. I've written down a few here. And what does the statement say? It says that the sum of two consecutive odd numbers. Consecutive means those that come one after the other. So when we add up two consecutive odd numbers, that answer is divisible by 4. So let's take the first 2, that is 1 and 3, and it says the sum. So let's add up. So 1 plus 3 is 4. And what does the statement say? The sum of these two odd numbers is divisible by 4. So the answer is 4. Is that divisible by 4? Yes, 4 ones are 4, isn't it? So when you divide 4 by 4, this answer by 4, our answer is 1. 4 ones are 4. So it is divisible. It is there in the tables of 4. Now let's take two other odd numbers, consecutive odd numbers. Now let's take 3 and 5. Okay, so let's add it up and see. 3 plus 5 is how much? 3 plus 5 is 8. And can you divide 8 by 4? Yes, 8 is in the tables of 4, isn't it? 4 twos are 8. That means this number 8 is divisible by 4. Now let's take another two odd numbers. This time let's say 9 and 11. Let's take 9 and 11. Now let's add up 9 plus 11. 9 plus 11 is how much? 20. And is 20 divisible by 4? Is it there in the tables of 4? Yes. 4 fives are 20. That means 20 is divisible by 4. That means this statement that says that the sum of two consecutive odd numbers. So we took two consecutive odd numbers, 1 and 3. Then we took 3 and 5. Then we took 9 and 11. And all these answers are divisible by 4. They're all in the tables of 4. We'll take one more example. Let's take 11 and 13. Okay, and add it up and see. So 11 plus 13. How much is 11 plus 13? 24. Now is 24 there in the tables of 4? Yes, 4 sixes are 24. So can you see, children? The sum of two consecutive odd numbers is always divisible by 4. So this statement we have verified. So let's write, hence the statement is verified. Question 8. In which of the following expressions has prime factorization been done? So we have been given a few expressions like this. This is the first one, question A. Now we are asked whether in this expression prime factorization has been done. Now what is prime factorization? When we put down this number like 24 into its prime factors. So let's just try just for 24. What are the prime factors? So 2 ones are 2, 2 twos are 4, that is 2 to 12. We're dividing 24 by its prime numbers, prime factors. Now we have 12, 2 sixes are 12. Then we have 2 threes are 6. Then we use 3, which is a prime number, 3 ones are 3. So what are the prime factors of 24? We have 2 into 2 into 2 into 3. And as you can see, 2 is a prime number. And 3 is also a prime number. That's why they are called the prime factors of 24. Now in our question here, we've been given 24 is equal to prime factors 2 into 3 into 4. Now let's multiply and see first. 2 threes are 6, 6 fours are 24. So we're getting 24. But has prime factorization been done? For that we have to check whether each of these factors is a prime number. Now let's look at 2. Is 2 a prime number? Yes. 3. Is 3 a prime number? Yes. Is 4 a prime number? No, 4 is not a prime number. That means in 24, in the number 24, prime factorization has not been done. So prime factorization has not been done. Question B. Here we have 56 equals 7 into 2 into 2 into 2. First let's multiply and see. 7 twos are 14. 14 2s are 28 and 28 into 2 is 56. So all these numbers, when you multiply, you get 56. But are these prime numbers? Now we want to see if these are prime numbers. Look at the first one. Is 7 a prime number? Yes. And 2? Yes. So 2 is also a prime number. That means in this number 56, prime factorization has been done. Question C. 70 is equal to 2 into 5 into 7. Now first let's multiply and see. 2 5s are 10. 10 7s are 70. Yes, we're getting 70. Now we have to check whether these are prime numbers. So 2, yes. 5, yes. 7, yes. So these three are prime numbers. That means prime factorization has been done. Question D, we have 54 and 2 into 3 into 9. 2 3s are 6, 6 9s are 54. We're getting back 54. But what about our prime factors? 2, 3 and 9, are they prime numbers? Now 2 is a prime number, 3 is also a prime number, 9 is not a prime number. That means 54 is equal to 2 into 3 into 9 is false, because in this case prime factorization has not been done because 9 is not a prime number. Question 9. Now this is a big question, so let's go slowly. 18 is divisible by both by 2 and by 3. And it is also divisible by 2 into 3, that is 6. So let's just take one example and try. Now first let's try with 18 itself. 18 is divisible both by 2 and 3. Now let's divide 18 by 2. 2 into what is 18? 2 9s are 18. It's there in tables of 2. Now let's take 18 and divide it by 3. 3 into what is 18? 3 6s are 18. So it's divisible by 3. Now again it says it's also divisible by 2 into 3, that is 6. Okay, so 18, it's divided by 6 and see. 6 3s are 18. So that means 2 into 3 is equal to 6. It's also divisible by that. Now look at the second part of the question. Here it says, similarly, that means just like the first sentence, a number is divisible by both 4 and 6. So a number, we can take any number and see whether it's divisible by both 4 and 6. So in that case, can we say that the number must also be divisible by 4 into 6 is equal to 24? Just like this. Here it was divisible by 2 and 3. And when you multiply 2 into 3, it was also divisible by 6. So here, can we say that if it is divisible by 4 and 6, it should be divisible by 24 also when you multiply 4 into 6? Let's see. Let's take an example and see. Let's take a number which is divisible both by 4 and by 6. Now 4 1s are 4, 4 2s are 8. Okay, so 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16. Now among these, there are many more numbers. Among these, which is the one that is divisible by 6 also? 4 is not divisible, 8 is not divisible, 12 is divisible, isn't it? 6 2s are 12. So let's take 12. So now 12, it's divisible by 4, isn't it? It must be divisible both by 4 and 6. So 12 is divisible by 4. 4 3s are 12. 12 is also divisible by 6. 6 2s are 12. Now the question is, can we say that it should be divisible by 4 into 6 equals 24? Let's see. 12 divided by 4 into 6 is 24. You can't do this division, isn't it? 12 divided by 24. It's not divisible by 24. Therefore, we cannot say that this number should also be divisible by 4 into 6 equals 24. Question 10. I am the smallest number having 4 different prime factors. Can you find me? Now this is like a riddle. So let's see. I am the smallest number. So that means we're talking about the smallest number. It has 4 different prime factors. Okay, now let's write down a few prime numbers. 2, 3, 5, 7, 11, 13 and so on. I've just written a few prime numbers here. Now, here this question says it's the smallest number and it has 4 different prime factors. So what we'll do is we'll take 4 of the smallest prime factors. These are the prime numbers here. We'll take the smallest prime numbers, the first 4, because it's about the smallest number. So let's take 2, 3, 5 and 7. So 2, 3, 5 and 7. So we have taken 4 different prime factors. Now we are going to find the product of these numbers. Product means we multiply, because that's how we find the prime factors of a number, isn't it? Once we find all the prime numbers that help in dividing that number, we multiply them. So here we have to multiply these 2 into 3 into 5 into 7. So let's multiply. 2 3s are 6. 6 5s are 30. Now 30 into 7. Let's multiply 30 into 7. 7 zeros are 0. 7 3s are 21. 210. That means the number is 210. So this is our answer. Let's go back to the question and check this again. I am the smallest number. So this 210, though it looks like a big number, this is the smallest number which has 4 different prime factors. And what are the prime factors of 210? 2, 3, 5 and 7. So we have found the answer. The smallest number is 210. With this, children, we come to the end of this exercise. Thank you, children.